All right, good morning. My name is Andy Walton. I'm a high school science teacher in Upper Moreland School District. The title of my presentation today is Influences of STEM Identity on the Computational Design Thinking. Designing buildings requires people with different educational backgrounds to work together, notably architects and engineers. Sometimes this is difficult when they have different priorities or approaches in design. Separate focuses in educational background between architects and engineers can create biases or communicational issues, making collaboration more difficult. Do these biases in education appear even before students might start college? Might students' self-identification regarding STEM influences what they care about? If we understand student biases around design better, then we can work to improve the interdisciplinary collaboration potential of graduates of an architectural engineering program. The focus of this research was to explore how STEM backgrounds impact computational design thinking. We evaluated the following research questions. Do STEM and non-STEM participants show noticeably different priorities in design? Do STEM and non-STEM participants show noticeably different performances in design as measured by building performance simulations? While previous research has focused on how computational thinking impacts student learning, this study goal was to explore different thinkers' interaction with the model and the design process. The study included a survey to gather data on the participants as STEM focused and non-STEM focused. And then a design challenge was presented to the participants to record how they engage with typical building design objectives. The design challenge was completed by exploring a parametric model that represented a building location site in Austin, Texas. A post-survey was given at the conclusion to gauge the participants' focus during the design process. From the survey data, the participants were rated by a STEM affinity score to quantify their backgrounds. The building model was designed with 10 different dynamic variables ranging from height, rotation, window and wall insulation. The objective of the challenge was to create a building in downtown Austin that had low structural weight and energy and high daylighting, all while staying under budget. In the video, you can see how when we move the variable sliders, the outcomes are influenced positively or negatively. When we looked at the results from the study, for design priorities, STEM-focused participants ranked energy, then daylight, then structural weight as the top priority. For non-STEM focused participants, cost, appearance, and daylight were the main priorities. For example, if you look at the chart, the STEM-focused participants ranked energy, right, and daylight as top priorities, where for our non-STEM focused participants, the cost, appearance, and daylighting were also top priorities. However, when we looked at the overall designs created by the participants, the final values did not show a strong correlation to prioritized categories. A design value score was calculated based on having low weight and energy values and high daylighting scores. Non-STEM participants had a slightly lower score, which indicates they better address the design challenge objectives. When you look at the graph, lower the bars, the better the participants address the objective. The same is true for the value score. As you can see with the value score, the non-STEM focused participants on the right tended to have a slightly lower score than the STEM focused participants on the left. The final building outcomes show a wide range of design, but there are no major distinct creative differences between our STEM-focused participants and our non-STEM focused participants. In conclusion, STEM-focused designers prioritized energy, daylight, and structural weight over cost and appearance compared to the non-STEM focused designers. Despite the stated design focus, non-STEM focused participants scored higher on the overall design outcomes. Future data collection is needed to explore deeper relationships between STEM focus and design. As we look to future work, this was a pilot study on graduate students to test data collection protocols. It laid the foundation for future research on how high school students are influenced by their learning styles and background in STEM. First, I would like to thank the NSF Building Education Research Experience for Teachers for their funding. Next, I would like to thank the staff of Penn State CSATs for their leadership and direction. And finally, I'd like to thank Stephanie Bunt, Laura Hinkle, and Dr. Nathan Brown, and the rest of the building design group for all their passion, support, and guidance over the past 2 summers. Thank you.